Let's do the same or a very similar procedure for this problem. First, let's calculate some relationships. Okay, let's find some relationships between these things that we can see. Okay, for example, what's one relationship that we have? Well, for one, we need to use particles. So let's find a relationship with particles. So what's one relationship that relates particles? You should know that the 1 mole of any element, let's say in this case for KNO3, because that's what the particles of 1 mole of KNO3 is going to be equals to what? You know, the 1 mole is 6.02 times 10 to the 23 particles of the element, of the compound. What is the compound? KNO3. All right, that's one relationship. That's one unit rate. What's another unit rate that we have? We need grams as well, right? So grams of O2. So one mole, right? 1 mole of O2 is equals to how many grams of O2? You look in your periodic table and you see the weight, the mass for O is 16. So O2 is going to be 16 times 2, which is 32 grams of O2. That's another relationship that we have. We have one relationship that converts moles to particles and particles to moles. We have another conversion that converts grams to moles or moles to grams of O2. What's another conversion that we need? We want to convert O2 to KNO3, right? So KNO3 and O2, what is the relationship? 2 moles of KNO3 produce 1 mole of O2, right? There's a 1 right there. So 2 moles of KNO3 produce 1 mole of O2. All right, perfect. I think this should be enough. I think this should be enough. This should be enough relationships to solve the problem. If we need more relationships, we need more unit rates, we'll figure them out. Okay, so this is the first step to find any type of relationship. So step number 1. What is the step number 2? Step number 2 is, let's put what's given. So what are you given? You're given 2.5 times 10 to the 20 particles of KNO3. And you want to convert these to grams of O2, right? Because that's what they ask you. How many grams of O2? So that's what you want. So we need to convert particles of KNO3 to grams of O2. So first, now let's go to step number 3, which is putting these relationships that we found in step number 2. So let's multiply times a fraction. And again, here you put what you want to get rid of. And on the top, you put what you want. So what do you want to get rid of? You want to get rid of the particles of KNO3. And the relationship that you know between particles, 4 particles, is found here. 6.02 times 10 to the 23 particles of KNO3 represents or is equals to 1 mole of what? Of KNO3. All right. When you do this, you will get 1 mole of KNO3 because the particles with KNO3 will cancel out. But you don't want moles of KNO3. You want grams of O2. So we need to do this again. We multiply by a fraction, by a unit rate. We use the first unit rate. What's another unit rate that we can use? Moles of KNO3. So why don't we use this second relationship? So 2 moles of KNO3 it represent or will give us, right, will yield 1 mole of O2, right? You can see that in the equation. All right. When you do this, you will get, again, this is what you want. This is what you will get. You will get moles of O2. We're closer because now we have O2, but you don't want moles of O2. You want grams of O2. So let's use another conversion. Let's use this last conversion. So again, multiply by a fraction. And the last relationship that we got was that 1 mole of O2 is equals to what? 32 grams of O2. Right? So this is, again, this is what you want. And we got it. We finally have grams of O2. So what we need to do is just eliminate particles of KNO3 with particles of KNO3. Remember, always cancel in diagonal. Okay, never cancel straight, cancel in diagonal. Cancel this mole of KNO3 with this mole of KNO3. And last, cancel, let me use for blue. Mole of O2 with mole of O2. There, we cancel in diagonal everything that we didn't want. And we just have grams of O2, which is what we want. Perfect. So the answer is going to be grams of O2. And for the number, let's just multiply the numbers on the top, which is this, 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 and this. 2.5 times 10 times 1 times 1 times 32. That will be 2.5 times 10 to the 20 times 1 times 1. We don't need to put that, so times 32. And on the bottom, you can put this right here, and this right here, and this right here. So 6.02 times 10 to the 23 times 2 times 1. Again, you don't need to put times 1. And you can just calculate this with a calculator. Okay, so let me do this in a calculator. Give me just 1 second. 2.5. Just 1 second. You can do this. 2.5 times 10 to the 20 times 32. Okay. This is 0.0066 grams of oat. And this is your answer. There, you got it. So this is how you do all the problems. Just step 1, calculate, find some relationships. Step 2, put what you're given and try to figure out a way to make from what you're given to what you want. And step number 3 is use the relationships in step 1 to put them in step 2 to get the thing that you need. The thing that you need. Okay, in this case is grams over 2. That's how you do all these problems.